Well, we got a service call on a walk-in freezer not working, and I wonder why. The door is propped open, and yeah, it's all iced up. It says cooling, but it's clearly hitting something here.
This video is brought to you by Heatcraft Refrigeration.
All right, I turned off the disconnect switch outside, but the evaporator fan motors are still running, okay? This is a Heatcraft INTELLIGEN evaporator, so it has a smart circuit board inside of it and it controls all the functions. Heatcraft specs in their installation and operation manual that the evaporator should have an independent power source from the condenser unit. The reason why they do that is because there is a low voltage transformer actually in this side right here that supplies the low voltage for the INTELLIGEN board. And that INTELLIGEN board is very susceptible to power fluctuations. So on the low voltage transformer, they do not want that coming from the power source of the condenser unit, just in case there's voltage drops when the compressor turns on and things like that. So this one I installed a while back and I followed the manufacturer's specs. It's always important to understand how this equipment is supposed to be installed and how it's actually installed, okay? I'm not gonna stand on a high horse and say I've never installed one of these evaporators and missed an installation best practice or something. I'm not perfect, but I always try my best, okay? Now I also wanna point out that we're getting a yellow LED on the INTELLIGEN display. It flashes different colors to tell you when there's alarm or issues. Right now, I can guarantee it's an issue because it's not noticing a superheat change in a certain amount of time, and the Heatcraft INTELLIGEN is always looking for that superheat change, and if it doesn't have it, it's going to trigger an alert, of which it has. It has a yellow alert right now. It is very rare that I come into a room that doesn't have a ton of stuff in it. Now this one has a few things. Looks like there's a couple benches in here, but it's not as bad as it could be. I have labeling that I wrote on the coil that says panel M, breaker 25 and 27 right here, walk-in freezer coil. There we go. Now the power's turned off. All right, so we've got severe amount of ice here, and I see a big problem here, and I'm gonna have to talk to, well, I'm not gonna have to talk to him because I had a previous technician help me with this. He no longer works for me, but regardless, we're gonna fix this issue. This is not a problem, but if you look, this right here, we have a door switch. Basically, when they open the door, you twist a twist timer and it pumps down the coil, or at least sends a signal to the coil and tells it to shut down. Well, if you look at how the wires were ran, that is a potential electrical short because they're ran where they can potentially rub out against the fan bracket right here. So we'll have to correct that. Luckily it didn't create a problem yet. It's obviously been working this way for a while, but still. Also, when you run wires like this, look at how it was ran. I hate it when wires are zip tied to this bracket, because this bracket, you have to defrost this coil a lot and you have to take it out. So it's not a good idea to zip tie them. But if you have to zip tie them, you want to do it in a way where they're not gonna have to be taken off every single time. So, but also you can do a double zip tie where you never have potential of them rubbing out. So we'll inspect these wires, but we got it turned off. We can't get the fan motors out, unfortunately, because of how iced up it is. So we're gonna have to defrost it, then pull the fan motors out, and then we'll fix this control wiring right here. All right, nice and slow on the low setting, and when I get around the fan motor, I'll turn it onto the mist setting, but I'm just trying to get most of the ice from behind the bracket, trying not to get it all over the motor. These motors have, they can kind of handle a little bit of moisture, but you still don't want to soak them, you know? But, all right, a little bit at a time. I guess I should address something. So normally when I have an iced up walk-in freezer, I want to check the defrost heaters first. So I'll throw the unit into defrost and test them while it's iced up. But I guess I kind of glanced over things. This is not iced up. This is only ice on the front of the coil. That's how I kind of said it was from the door being left open. Because if you come back over here and you see, it's not even iced up there. It's just iced up on the front of the coil, basically. But we're still gonna test the heaters and make sure everything's working properly. And on my last clip, I showed the back of the coil. That was just frost. That's normal. It wasn't iced up through. I could see through it. So I was able to just break free most of this stuff just using the mist setting. Got that one done too. It's not iced up on the back. Now there is a little bit of frost and ice in here. I went ahead and loosened. There's two screws right here and right here. this whole thing kind of moves to the side, and then I pulled the 2 screws for the transformer so that way I don't have to soak it. And then we're gonna rinse all that stuff out real quick. So I always keep a headlight in my bag so that way when I'm working on these jobs, you know, it makes easier illuminating things. Now my flashlight has a flash, but you know, obviously I'm not holding that while I'm working the entire time. So I guess I should say my phone has a flash, but so you can see this wire. So I'm gonna redo this. You can see how it was ran. You know, not our greatest work. So luckily, like I said, we were able to fix it before it became a problem. And that is just control voltage, but still. This is literally going to a twist timer. So I'll fix this real quick and we'll run it down here, zip tie it to all these wires, and it won't have hopefully anything to do with the brackets ever. It really was not that hard to grab the wires, pull them down through that knockout instead of that one up there, and then just zip tie them to these wires, right? Running through that nice and safe. There's little knockouts, keeping the wires safe. Nothing's gonna rub, nothing's gonna hit. There's no metal brackets in the way. It's good. And then coming out here, connecting right in here. So we're good to go. Kind of comes over here, fishes through there. So yeah, that's much better. It's a much better way to do it. All is good. We're gonna put this guy together and then test the operations. But I don't think we're gonna find anything else wrong other than them leaving that door open all the time. All right, now we've got power turned back on. So there's monitor on here. It's gonna be a few minutes before it turns on. So box temp's 34 degrees, box temp set point -10. Operating mode is off because it's in a delay right now. It'll take a few minutes. Date information is correct. Don't see any major problems. You can see it's pumped down right now because our suction pressure is at 4 psi. EXV is completely closed at 0 steps. There's that board voltage that's very, very critical, so they're worried that it might dip. Also, that transformer is tapped for 208 volts. You can tap it for 240 or 208. You got to make sure it's tapped correctly because that'll mess with the board voltage. Everything's looking fine, so we're just waiting for it to turn on, and then we'll check the system operations. There was no ice back in here where the EEV is at, so there's just a couple sensors. You're gonna have a pressure transducer back there. You're gonna have a couple temperature sensors, suction line temp sensor, evaporator temperature sensor, air temp sensor. But we'll check everything and make sure it's all working. All right, so condensing units opened up, system is running. Nothing out of the ordinary in here. Evaporator coils are running. See, we've got everything labeled. We installed this in 5/21/20. Sight glass is clear, so that's good. So we're just gonna let it come down in temperature, nice and good, and then we'll test all the defrost heaters and make sure everything's good. All right, so now we're just looking at the low side. Looks like my superheat's about 2 degrees, 3 degrees. That's what it says on the board too, so that looks good. There's nothing funky going on in here. Pressures look about right. We can compare them to what this guy says. Suction pressure, 14 PSI. That's about what I'm reading on mine. So everything looks fine. I don't see any issues as far as refrigeration goes. So with that being said, let's go ahead and push this guy into a defrost. So we'll go home and we'll change it to defrost settings. We're gonna go to force defrost. It's gonna ask for the expert pan. I believe that's all 9s if I remember right. There's 2 pans to be concerned with, all 8s and all 9s, and I believe the expert pan is 9. There we go. We're going into a defrost and we're pumping down. The fan should shut off and then we should be able to test all the defrost heaters. All right, so if we just come up here to N, we have 201 volts. So that's good. And then now we just need to test current on the different heaters. So there's one at the bottom of the coil, one in the middle of the coil, one at the top of the coil, and one in the drain pan. So there's 4 heaters total. If you look at all the wires on one of the terminals, the H2 or the H1, you'll see that there's 4 wires on each one. So we have to get a current reading on all 4 wires. That's one of the coil heaters, 1.08 amps. That is a drain pan heater, 1.11. So now we have 2 more coil heaters to go. There's 2 amps on one of them. Make sure I'm not getting anything else. Nope, that's one of the coil heaters. And now we got to jump on the last coil heater. 2 amps on another, 2.3. So we're good to go on that. So that looks good. That should be this wire right here, if I remember right. If I can get this on here. There you go. And there's all my heaters running together. So all my heaters are fine. Don't see any problems there. We'll inspect the relay on the other side because I have seen issues where it melts and stuff, but I don't see any issues here. Limit switches don't seem to be a problem. So it's defrosting right now. You always want to look in here. They give you LED lights to tell you what relays are energized too. So that's kind of cool. Turn that off and you'll see. But yeah, I don't see any issues with the defrost terminals. Everything looks fine there. I don't see any issues here. Nothing telling me that there's a reason why this thing iced up other than them leaving that door open. So, and judging by where the ice was, the defrost heaters were taking care of the coil. The coil was defrosted. It was just built up in front of the coil. So, and that, the sensors and the heaters can't really tell, and that's just misuse basically. So we can run through the settings here just to make sure all is well. So if we go into here, it says we're still defrosting. It's electric defrost. It's using demand defrost, so it's only defrosting when it needs to. Since 12 a.m. it's done 4 defrost, so it has an algorithm built into it. The fail-safe time is 45 minutes, and the temperature at which it'll end is 60 degrees at the coil sensor. After it defrosts, it has a 2-minute drip time, and it does not have dual coils. Everything else looks fine. It's defrosting, so we're gonna go ahead and end the defrost, and then we'll restart this. All right, overall everything looks good. I don't see any problems. It's very important when you're working on these INTELLIGEN systems or QRC systems. They're similar to a beacon system, but they don't have any communication outside, and if they don't have communication, you cannot have any time delay relays according to Heatcraft Tech Support and their installation manual. So if it's a beacon system and it has low voltage wiring coming out, you're allowed to have time delay relays, the ones that come with the system. But this is a off-the-shelf condensing unit, and from the factory it comes with a time delay relay to prevent short cycling for the compressor. But with the INTELLIGEN system, because it doesn't have communication outside, we cannot have that time delay relay. So we did our job correctly on install and removed it. It was right there. You just have to make sure that your pressure control is set accordingly because you don't want the short cycling on, off, on, off, on, off. Other than that, everything else is good. Don't see any major issues out here. Liquid injection, this guy right here, you can tell it's working because it's very, very cold right here. Okay, so this takes liquid coming from the liquid line, coming out of the expansion, out of the dryer. After the sight glass, solid column of liquid goes through a solenoid valve that whenever the compressor energized, that solenoid valve opens, and it dumps liquid into the head of the compressor to try to cool it off. Because when you have the high compression ratio situations that you get in a low temp environment, those compressors can get really hot on the inside, so they actually inject liquid and meter it. So this is a metering device, really, is what it is. So it's coming out, 90-degree liquid, 80-degree liquid, and right here is probably 45 degrees. So it's injecting into the head of the compressor. Sometimes they do it like this. Other times they have a DTC valve, a discharge temperature controlled expansion valve, basically, that has a sensing bulb that goes in the head of the compressor right here. But because this one has the capillary tube or fixed orifice style, that's right there, okay? So if you ever have this, you have to make sure that that solenoid valve is installed, because you do not want this in the off cycle. You do not want liquid migrating into that compressor. So this one has a solenoid valve, and if you follow the wires back, what's actually happening right down here in the bottom, that little blue thing that says R&K electronics, that's a current sensing device. So when it senses the current of the compressor, it sends power to that solenoid valve, and that energizes and allows liquid to go in. So, all right, we're gonna put this guy back together, go inside. I don't know what happened right now. Either satisfied, it might have satisfied, it's hard to say. So I'll run in there and see what happened there. They may have turned the twist timer too, because they have that pump down timer on the door. So we're gonna put this guy back together, put all the caps back on, and go check out the evaporator again one more time. So yeah, they did what they're supposed to do, and they have the twist timer turned because they're loading the box right now. But so it's in product load mode. Yeah, everything else is going to be fine. I'm just going to make sure this guy turns back on, but let's talk about the INTELLIGEN real quick. So the INTELLIGEN is a standalone controller that operates the EEV, and the EEV actually operates as a liquid line solenoid valve. So they use the EEV to pump the system down. It's got an evaporator sensor, suction line sensor, and an air temperature sensor, and then a pressure transducer. And with all four of those components, it's able to regulate the superheat, make the EEV open and close, and then there's logic in this guy, and this acts as the temp control too. Now the unit still does have a defrost termination switch and a heater safety just to be safe, or actually it still has a heater safety. But yeah, other than that, it acts as a normal freezer coil. There's nothing too complicated about these things. So it's just about how, so it looks, it even tells you they've got 19 minutes left before it automatically turns the system back on too. All right, it's back on and running, everything's good. So we're gonna give them the keys and tell them to keep an eye on it.
So when the customers ask us, why does our box keep icing up? Well, this is why, right? You can't prop doors open. Now, unfortunately, with the craziness going on right now, it's hard for restaurants to have, staff that lasts for long periods of time, right? There's a high turnover rate in the kitchens right now, and it's difficult for the restaurants to get people staffed up properly. Now, I'm not necessarily making excuses. I'm just observing, right? I observe from the outside in, and I'm able to say, and I also have a direct line of communication with management too, and higher up, corporate management and stuff, but they know it too. But this is a struggle. We're having constant iced up evaporators, walk-in coolers, freezers, all that, because people are leaving doors open. It's horrendous. Now, I'm trying as hard as I can to try to get the higher ups to approve me to remedy these situations with door alarms, with curtains, with air curtains, with different things, but man, they don't want to spend the money on that stuff, okay? In this situation, it's actually not that difficult on an INTELLIGEN evaporator. All they have to do is allow me to mount this board on the INTELLIGEN module. This gives us the ability to have internet connectivity with the INTELLIGEN evaporator. Okay, it's got an Ethernet port on it. We can program it and set it up, and the customer, myself, whoever we designate as the person that needs to get the notifications, can get the notifications when something bad happens. This is a Heatcraft part. Heatcraft makes these available, so you can order them. Part number on this is a 289-18301. Not too difficult, and if they had this, then they could, have the internet connectivity, and, then they could be alerted and notified, okay? So it really comes down to the customer understanding how their product is supposed to be used, okay? Now, we have a door switch that's a twist timer, okay? That twist timer, when you twist it, it's a 15-minute timer. The evaporator shuts down, the motors turn off, and it's a product load switch is really what it is. It's for them to go in and out of the box, and they're supposed to turn that. Now, occasionally they do, but then other times they don't. And I try to advise customers as much as possible to not put things by the doors, because that's where the cooks, when they're coming in and out. Now, this kitchen staff and, again, outside looking in, these guys are overworked. They're coming into this. They're under pressure. They don't have time necessarily to take their time and make sure everything's, correct, make sure doors are shut and all that stuff, because they've got food that's going to get burnt or different things like that. So it's just kind of a game you have to play when you're in the restaurant industry, okay? Now, as far as going through the equipment, I needed to fix some issues because we did install the equipment, but I was not part of the person that had ran the twist timer wiring, right, or the door switch wiring, and I wasn't too happy with the way that it was ran. It was ran in a method that potentially could have caused a future breakdown, okay? And luckily, I found it before that happened, okay? And I was able to correct it, fix it, so that way we didn't have any more issues, okay? Other than that, I mean, it's a typical walk-in freezer evaporator and INTELLIGEN install. Very important when you're doing the INTELLIGEN equipment, the QRC equipment. you know, you want to make sure you have independent power sources for the evaporator. Now, this can be a challenge when you're installing these INTELLIGEN evaporators, the QRC evaporators. The QRC is kind of the legacy ones, right? They're not really manufacturing those anymore. It's the INTELLIGEN. But you know, you need to follow the manufacturer's installation instructions when you're going through this equipment, making sure that you install it according to their spec. And if you don't, there potentially could be repercussions, and you have to be prepared for those repercussions, okay? In this situation, you know, they're concerned about, you know, voltage issues. That circuit board is very, very susceptible to voltage fluctuations. You know, they don't want to see very low voltage on that 24 volt evaporator, basically. So that's one of the main reasons, maybe not the only reason, but that's one of the main reasons why they want an independent power source for the evaporator. And the point that I was trying to make is, on the older equipment, we used to power the evaporator from the outside condensing unit, but that does not work on this new equipment. It's just how things are happening, right? You got to make sure you follow their installation instructions, and then you should be problem free, besides, you know, occasional issues or customer abuse in this situation, right? This is happening more and more, so it's kind of crazy. But I really appreciate y'all making it to the end of the video. Thank you so very much for your support. Do me a favor, leave me some feedback down in the YouTube comments. Let me know what you think. Hey, I'm open to criticism. I'm open to feedback. If you got it, put it in there. Put it in the comments and let me know what you think, okay? I really appreciate you all, and we will catch you on the next one, okay?